Hi, I'm Dr. Donald Gann, and after a long career as a surgeon and physiologist, I've come here today to tell you about a discovery we made in my laboratory, which I believe may save many lives. During my career, I saw far too many patients who could not be saved after they sustained horrific injuries caused by guns or motor vehicles. Often, it seemed that given extra time, a patient's life could have been saved. This would drastically reduce the number of deaths from injury down from an estimated 5.8 million per year worldwide. With over half a century of experience treating and studying this problem, I'm excited to tell you about our discovery and how I believe it will be able to extend the window of opportunity to provide critical care for trauma patients and hopefully reduce the number of senseless deaths caused by injury. The body consists of millions of cells. Cells have the ability to swell and also to shrink. This can be caused by many factors, and the outcome varies for the response from the body. In hemorrhagic shock, there's a sudden and significant loss of blood or body fluids that cause a loss of blood volume. For trauma patients, the biggest thing they are fighting is the onset of hemorrhagic shock. This condition sets in if they lose too much bodily fluid. Unfortunately, once shock sets in, it's incredibly hard to reverse. Today, patients are treated with saline and plasma to help keep their fluids and pressure levels up while moved to the hospital and while receiving treatment. This is helpful in some cases, but once shock sets in, these fluids do not reverse the condition. The time for available treatment decreases quickly. With shock being so hard to reverse, the biggest factor in patient outcomes is time. How quickly was first aid started? How long did it take paramedics to arrive? How long to get to the hospital? How long to get to potentially life-saving surgery? This is why most major cities have fleets of helicopters to transport patients to hospitals as quickly as possible. However, time is limited, and even with the most advanced transportation services and best medical practices, there's often not enough time to save the patient. In medicine, the term golden hour describes the window of opportunity to provide critical care to a patient. This is because once hemorrhagic shock sets in, the patient has about 1 hour before their odds of survival decrease significantly. Inside the body, what is happening is more complicated. The body has a command system. It turns things on and off in different situations. In injury, things happen that aren't normal, and the changes that occur, while seemingly simple, cause catastrophic results. What is most important to understand is that once shock sets in, one of the most important components to every cell in every living thing shuts down. This component is the sodium potassium ATPase enzyme, which is vital to keeping every cell in our body alive. And an enzyme is just a substance which allows a chemical reaction to happen. So what researchers have found is that when shock sets in, the sodium potassium ATPase enzyme is inhibited. This inhibition prevents these chemical reactions from happening, which are vital to all cell life. These changes can quickly lead to death of the patient. Shock is a condition which we have known about since 4 AD. This word comes from the old French word choquer, meaning to strike against. But why and how the body was striking against itself is something which has perplexed physiologists since its discovery. In the early 1900s, researchers found there were things other than blood cells circulating in our blood. With this discovery, some began searching for a toxin that could be released in the body after injury, striking against the cells and leading to death. They were never successful in finding a toxin and concluded none were there. Back in the 80s, a colleague of mine discovered there were signals sent to red blood cells during shock. Knowing the body sends signals using chemicals, I set back out on the search for a toxin which many before had looked for, but did not yet have the tools to find. My lab worked to purify blood samples from rats who had died from hemorrhagic shock, and eventually we were able to purify it enough to find there was an incredibly small toxin. Antibodies are proteins produced in the blood which can capture toxins, as well as other foreign substances, and render them harmless. To see if shock could be reversed by neutralizing this toxin, we set up an experiment with rats to test the antibody. These rats went into hemorrhagic shock and were left untreated until they had less than 5 minutes to live. At this point, it was certain that they would die and could not be saved, so we administered the antibody to them with some fluids. To our surprise, their blood pressure rose and they began to look normal and healthy. These rats started chewing on their restraints and could run around after being given just this antibody and some fluids. More amazing was 15 out of 16 of these rats survived the full 4 hours of the study. There are two main markets which desperately desire a product like this. The first one is where I have the most experience, and that's treated civilian patients after trauma, mostly from car accidents and gunshot wounds. In the U.S. alone, over 250,000 people die from this every year. The other market which needs this treatment and has already shown its interest is the military. More than half the military deaths in Iraq and Afghanistan were caused by shock, and too often the men and women protecting our country are unable to get the treatment they need in time. With the closest trauma center located in Germany, I believe this would allow many more troops to receive better care, as they could now be stabilized and transported to Germany for treatment rather than having a major operation done in a tent in Kandahar. While obviously hemorrhagic shock is a major issue, I want to tell you about two other types of shock which I believe are likely being caused by the same or a very similar toxin. The first is cardiogenic shock, which is caused by a blockage to the heart, most commonly a heart attack. As with hemorrhagic shock, time is the biggest factor here, as 25% of these patients in the U.S. die before making it to a hospital. The second condition is called septic shock, which is caused by a severe infection which gets into the bloodstream. This is the leading cause of death in U.S. hospitals, as it too often sets in and kills the patient before doctors are able to identify the bacteria causing the infection. So once again, we run into the issue of time. While we are working on testing our antibody for hemorrhagic shock, we will also run pilot studies to see if these two conditions may be treated with the same drug. Everyone knows someone who has needed this treatment or who will need it. There are an estimated 5.8 million deaths from hemorrhagic shock worldwide every year. And while there is more to be done, including the completion of preclinical experiments, we are prepared to continue and complete this work upon receiving funding so that we can bring this treatment to the world. We hope you will help.